Welcome back. So previously we have just talked about the concept of spanning tree. So without any waste of time, let's just jump to what we have talked about lastly, which is the election. Election must happen first to know which interfaces will stay up and operating and running. After eliminating or after knowing all the interfaces that I need all of these maybe to be up, and all of these 5 must be up. So this one is the last one. I'm sorry, you will be the victim, so you have to be disabled. Okay, so this is the concept of, or this is the reason of election. Okay, so now back to election. The first rule, we must elect what is called the root bridge, our main device. Okay, it was called a root bridge because spanning tree was invented in the time that switches were called bridges. So when bridges developed to become switches, the concept and this term was remaining as bridge. Okay, no problem. So the first thing we need to do is that we must elect a root bridge. It's not manual. This is already automatic, as we have mentioned. This is already automatic and will happen entirely and completely without any manipulating or configuring from you as an engineer. Okay, you can implement all of this. It's a resilience in the future, but as a CCNA engineer, just know what's happening. Okay, so first elect the root bridge. The root bridge is one of these switches which has some specifications that qualifies it to become a root bridge. The first qualification is that it must has the lowest bridge priority. I hope my font is clear. Okay, the lowest bridge priority. What is bridge priority? Bridge priority is a logical number that do already be manufactured inside switches when they are being manufactured, and as a number it has the range that starts from 0 up to 65,500 and I believe 35. Yes, since it starts from 0, then it will be to 565,535. Okay, so it's a number that ranges between these two numbers in this range. But by default, if you did not manipulate or change the number by yourself, then in Cisco devices out of the box it will be 32 and 768. Okay, I believe it was 32. We will just check it in the lab in the pack tracer, and 768. So this is the first rule, that the lowest bridge priority in whomever one of you three will become, that's it. So the lowest priority will automatically become the root bridge. But because these 3 switches, all of them might be, I have just bought 3 switches from the market, so 3 of them are new, 3 of them out of the box, and by default then the 3 of them will have this bridge priority. So all of them are equal in bridge priority. No problem. This will lead us to what's called a tiebreaker. And the tiebreaker is another rule. We should look at it. There is no C in here. Okay. Tiebreaker is a rule that we should look at it if the first rule did not help us. If the first rule failed to judge or failed the election. Okay. So our tiebreaker, our second rule is to take the switch that has the lowest MAC address. I really love MAC addresses because in spanning tree and in IPv6 they always saves us, because MAC addresses never gets duplicated. These 3 new out of the box switches, each one of them came manufactured with a unique MAC address. Okay, so the lowest MAC address will win the election. Okay, so let's say that the MAC address of this one was about 0, 0, 4 zeros, maybe 4 ones, and maybe 4 A's. This is the first one. On the second one, maybe the MAC address was maybe 4 zeros, 4 ones, and 4 B's. The third one, maybe 4 zeros, 4 ones, and 4 C's. In the hexadecimal word, 0 equals 0, 1 equals 1, 2 equals 2, up to 9 equals 9, but A equals value of 10, B equals the value of 11, C equals the value of 12, finally F equals the value of 15. So all of these zeros, we can avoid looking at them because they are equal. All of these ones, we can avoid looking at them because they are equal. So after that, I have A's, B's, and C's. So these 4 A's means 4 10s, these 4 B's means 4 12s, and these 4 C's means 4 11s, I'm sorry, and these 4 C's means 4 12s. 48, 44, 40. So which one of these 3 switches has the lowest value of a MAC address? I hope that you have so far become convinced that it will be switch 1 or switch A. Okay, so switch 1 will win the election and will become our root bridge. So this is only the first step of, I'm sorry, of electing of the spanning tree process. Just elect the root bridge. Okay, so I will clear all of this. Now we are convinced that this switch 1, is our root bridge. Okay, switch 1 is the root. This is step number 1. Elect your root bridge. Step number 2, which is automatic. Okay, don't get confused about it. How much ever, no, this is not in English. Okay, whatever ports, or no matter how much ports, okay, no matter how much ports does the root bridge have, all of them, 1, okay, it's possible to be 1, 2, 3, 4, maybe 48 ports are available and working in the root bridge, all of them must be up. All the root bridge ports will automatically and forever be up and running. They will never be disabled. You want to know which ports will be up. Okay, this is your concern, not the disabled port. Your up ports, you want to know your service will go through which ports will stay up and running. Okay, so you have known that all the root bridge ports must stay up. So I know my switch 1, my root bridge has only 2 ports, so automatically these 2 ports will stay up and running. Okay, and after they are up and running, each one of them will be called a designated port. DP stands for designated port, and the designated port will always have the state of forwarding. It will always forward data and information. It will not stop or block anything. So this is okay. Step 2 is done. Step 3 is another thing. What is so wise of having 2 ports up and running if their opposite ports were disabled? If this port was up and running always and it was forwarding, okay, what's the benefit of this if this port was disabled? Or maybe this port that is opposite of a designated port is disabled. This will make spanning tree useless. But don't worry, by default, whenever there is a designated port, it will always, okay, that is facing a designated port of the root bridge, whatever ports that are facing the root bridge, they will always stay up and running. Okay, so 3, our third rule. This is the second, this is the first. Okay, the opposite of the designated ports of the root bridge will always be up and running. Okay, so these two will forever be up and running in spanning tree. They will be called root ports. This one also will be called a root port. Okay, so RP stands for root ports, because these ports, this port in the switch is what leads this switch to go back to the root bridge, and this RP in this switch is what leads this switch to go back to the root bridge. Okay, so that is what makes these ports called a root ports, and root ports do have the state of always for forwarding frames, max, and information data. Okay, so this is the third rule. Now, in my topology so far, I have 1, 2, 3, 4, 5, 6. I have 6 ports. My concern is to know which ports will be up. So far, I have collected 4 out of 6 ports that are up and running. This is the total. Now I have only 2 ports left. One of them must give a sacrifice. Okay, so either you or you must give a sacrifice and become disabled port. Okay, so that the other one will be called a designated port, and this will be in the state of redundancy. It will be a standby. Don't worry, this will not be disabled forever. In the concept of spanning tree, we did not mention that what will happen if this active link fails. This redundant link will automatically gets up and running. This disabled port, if this was the disabled port, this will become a designated port and it will work. It will run. This will become the root port, sorry. And it will run, okay? It will operate. So if I had this topology, then by default, this interface is down, okay? Which leads us to this topology, where everything is working without a loop, okay? If something happened to this cable or port for whatever reason, spanning tree do automatically get this port to become disabled and operate this port. So we will have this new topology. So the 3 switches are back to be connected again. This is the benefit of spanning tree, okay? Not just avoiding the broadcast storm, but also to maintain redundancy. So yes, spanning tree do maintain redundancy after all for us. We haven't lost redundancy, okay? So because without the need of spanning tree, we can just unextend this cable and everything is solved. But no, for redundancy, we will extend the cable. Spanning tree will make it a standby cable. Once there is a problem with one of these 2 cables, all existing cables, spanning tree will operate this interface until the problem of this cable is fixed. So spanning tree will re-disable this one. Okay, so this is the concept of spanning tree. So where have we reached? We have reached that 4 out of my 6 ports are up and running. One of these 2 must be temporarily disabled and become a standby interface until a problem occurs in the future, and I will make use of it. But which one of them? You remember that the lowest MAC address of these 3 was the first one. After that, the second lowest MAC address was switch 2, since it has B's in its end, or I believe it was switch 3. I'm sorry, switch 3 had maybe B's in its end. B, it was this way, 0 0 0 0 colon 1 1 1 1 colon 4 B's, and in here it was 4 zeros colon 4 ones colon 4 C's. So I do know this root bridge, but I'm confused between these 2. One of them I need to know what I need to know which port will be disabled, or I need to know which one of these ports will stay up and running. I need to know which one of these ports will stay up and running. Okay, so which one of those will stay? I have elected my root bridge because it has the lowest MAC address. Okay, or the lowest priority, depends on that. The second lowest MAC address is the one that will have its port up and running. So I'm sorry, you, because you have a heavy MAC address, will have to make your port give a sacrifice and become disabled. Okay, so the third type of ports, I'm sorry, I must clear all of this, or maybe let's just try to clear this. Yes, this will be good. Okay, so what will happen is that the third type of ports is called a BP, which is this one. This will become a blocked port, and this one, the lucky one, will become a designated port. The blocked port will be in the state of alternative because it is a standby. It's an alternative port for these two links. Whenever one of these two links fails for any reason, this alternative will become designated and it will serve the network and make it maintain redundancy. Okay, so this is the process of election. When this process finishes, I know my port roles. I know that this one will become designated port, a root port, a root port. Finally, this one will become designated port and this one will become my blocked port. Okay, so this is the process of election. Okay, I have known which one is the designated, which one is the root, which one is the alternative port, which is in the blocking state. The entire process of election, starting from the root bridge until all my ports are known, takes from 30 up to 50 seconds. These are contained from, first of all, the maximum age when a loop is about to occur. Okay, the first maximum age is 20 seconds. Okay, plus the process of forwarding will take 15 seconds and the process of learning will take 15 seconds. What's learning and what's forwarding, please? Let me tell you that through these 50 seconds, what's happening is that spanning tree is by default disabled in all these switches when there is no need for it. Once you connect your third redundant cable for redundancy, what will happen is that all the interfaces will go up to become in the state of listening. Okay, all of them will be in the state of listening to listen to the process of election and know what's happening. After listening, they will go to the state of learning, and learning will take about 15 seconds. After learning, we have our ports either become a designated or root ports that will make them in the status of forwarding, or my interface will be in the blocking state. Okay, so these 6 ports, all the 6 of them has a spanning tree disabled. After that they will become all listening, all will become learning. After learning, 5 of them became forwarding and only the last one of them became blocking. So all of these steps, all of these layers and levels takes about 50 seconds to complete. After that you'll have one redundant alternative port and the others are up and running normally. Okay, so this is all the process of election, all the process and the concept of spanning tree. Let's see what do we have up next in our slides. We have other types and generations of spanning tree. Okay, but before that we will stop this video. We will start and establish another one. In the other video we will perform a lab just to check and verify spanning tree. Okay, after verifying we will go back to this one to finish the other versions and releases of spanning tree. Okay, I hope this was informative for you, just to check what are the elections, what's the concept of spanning tree. Please comment for us below in the video for any question you have about it. We will be more than glad to aid you with. Okay, so thank you for watching and we will see you very soon.